got a Patriot going in today, and it's going to be pushed to open. So the actuator arm is going to be on the inside, and the gate's going to go out just like that. So as usual, the first thing that I do is I mount the housing. So you can see that I mounted it. I forgot to drill that one right there, so it's fine. I drilled those as a, I'm putting a lot of weight on it right now. I drilled those, this one and this one, as a precaution, just in case these two don't bite. So this one right here is no big deal. I'll put a little silicone in there. Probably don't even need to do that. It's underneath a lip, as you can see. So I'm not even going to worry, which is underneath this eave, so I'm actually not even going to worry about that. We'll have a qualified technician run power from here and get me an outlet over here, and that's where I'll put my transformers right here, and then we'll worry about getting the arm. Still got to get a saw cut across the drive, so that's not done yet, so that won't be done today. We've got transformer plugged in, got the battery connected, and then you can see that I've got the and I got my flash on, so it's kind of hard to see now. There's a better angle. You can see that it's charging and that it's got external power to it. It should be fully charged, so it'll charge, I guess, here in a second. It'll get the last part of that charged up, and we'll be good to go. But anyways, it'll be charged before I start running it. So we're good there. I'd like to top these batteries off before I run them. So we're good there. So that's what it looks like with just the housing on there. I just don't have anything connected to it operator wise. The operator's still over there on the ground, and I'm getting ready to weld all the stuff up there to it, and then work on the arm and get the actuator cable installed wherever it's at. And get the actuator cable installed. I'll mount that. I'll do all my connections inside the actual inside the arm, so there's no splices other than the splice that's over here on this side. So that's what it looks like, and as you can see, I got everything charged. So that just took about 5 minutes for it to fully charge, because I already had it charged from the shop. So that's how she looks. I'm gonna install some actuator cable for this Patriot arm, which is going to be installed on the opposite side of the control housing. So this will allow us to extend this actuator cable and run it across the drive. So you could do it a couple different ways. You can cut it off right here and then make a splice. It's not uncommon to do that, and sometimes you have to. In this particular case, I'm just going to go ahead and void the factory warranty and run the actuator cable that's going to go across the drive into the housing and make all my connections in there. That way I don't have to worry about a splice point, and then all the connections are inside the weatherproof housing, and it's going to give us a better connection, if you will, if we do it in here to the factory connectors. And that's it. So this will take about 30 minutes, and I'll go ahead and start that right now. And the first thing you do is cut the actuator cable off, take these 5 bolts out, and then disconnect all the factory cables, factory connections from this cable, and then put new cable on there. And that's what it looks like after the 5 bolts have been loosened. I can't see anything because of the way the damn sun is. So we got 1, 2, 3, 4, and 5. So I just used an impact wrench on the lowest setting and backed them off with a 5/16 nut. And then now what you can do is just take your screwdriver, and then you can just put it in the back of the housing, and then just break the seal just by putting a little bit of pressure on it, and that'll break that seal. Now we're lucky here because it got a pretty clean break across it, so we don't have to replace the seal. And then now we'll just make our new connections in there. And on these, I wog it WOG, white, orange, green, WOG it. So if you forget, that's the order that it goes in, white, orange, green. And we'll make new spade solderless terminal connectors there, and then we'll make new connections here for the motor. Okay, I took the heat shrink off of the positive, the hot wire going to the motor from the control board, and this is the part that's going away, and this is what we're staying. That's what's staying. Here's the step that I did. What I did is I took a razor blade and just cut it back, and then once I got it back to there, I took the side cutters and then just cut all the way along up there, and then take it out, and then I'll hold on to this part of the cable, this cable right here, because that'll tell me how long these are. Once I'm making the new putting this part of the actuator cable on there. Once I'm putting this on there, I can feed my insulation all the way up to here, and then I'll know how far the wires have to be sticking out in order for me to make a good solid connection here. It's going to be kind of tough to see, but this is the wire that actually came off of the actuator arm. Now it's going to be really tough to see, but on that red wire right there, you can see right there's a little nick, right? And where that nick came from is when I was scoring the jacket in order to strip it back so I could expose the wires, a little nick happened. So you got to be aware that that's going to happen when you're doing your wire and you're cut back the jacket to expose the wire. So what you do is you cut it back this far, and then you make a little niche right there, and then you strip the wire back from there without actually cutting. That way you get past all these little nicks, because you don't want any of those little nicks in the insulation of the wire itself. And it will start to oxidize, possibly corrode, depending upon what's in the air, and add resistance to the wire. And that's one of the three faults in a wire: short to ground, high resistance, or an open. And you don't want any of those, and you definitely don't want to start it off bad by actually nicking the wire. And then here's the one that I just stripped back, and you can see that what is that? The green one is nicked. The green one is nicked, the black one nicked. They're all nicked because I was not worried about that. I'm just going to pull the jacket back from there by stripping it back with some snips, or just physically just pulling the cables apart and get past this, and then I'll cut this off and have a good wire. But now you can see why I saved this part, this wire right here, that wire right there, is because now I can get my distance once I get good cable and see how long my wires need to be. So you can see I've got the wires cut to length using the old cable as a gauge. I would just put it right next to it and just started cutting them off at the same lengths that they were, with the exception of I staggered white, orange, and green, making white the longest, then orange, then green. And here's the stages of termination. So white has had the insulation stripped back and a solderless terminal connector crimped to it, and then orange has just been stripped back, and then green has the insulation still on it. So this is what it looked like. Then it goes to this stage right here, just being stripped back, and then we actually put a connector on it, and then we'll make the connection there on top of the board. But we'll do green first and work our way up, and then we'll worry about the power connectors for that run voltage to the motor. Worry about those in a second. So I've got the white, orange, green tied in, and then I've got my power to the motor tied in. I had to use these connectors. I just cut the factory connectors off, and then I had to put these other connectors on because I didn't have a size that would match. So this looks like it's weird because it's got two females going together. Well, actually this female actually has a female and a male on it, so I bent the male up to plug into this other female. You may have seen them before. So you can see that I used some heat shrink to make that connection a little bit more rigid and not as susceptible to bend and break. I'll zip tie it as well too, but gives you a little bit better idea what it looks like when it's all done. And that connector that I used was like this, but it was obviously for a different gauge. So I just bent this little tab up right there, and then as you can see, there's plenty of, it takes some effort to bend it, but you can see that it's one solid piece, so it'll be plenty rigid for this. Especially what I'm going to do is I'll recess the red wire, red and excuse me, yeah, red and yellow, which are common and positive. I'll recess those in there, and then I'll just zip tie these together. So I'll show you how that looks here in a second. So that's what it looks like when it's all zip tied and ready to go. And you can see I got my white, orange, green. I'm just confirming that I got it right. From the top to the bottom, white, orange, green, I call wog it. And then I've got the cable zip tied in there. And then I've got the motor wires recessed back in there. So that should be a pretty good install. None of my wires are tied in there. And I did catch that the green actually was not pushed in all the way. And you got to be careful of that when you have this insulation on these connectors. You can actually plug the male counterpart of this in between the top and the insulation of the jacket that goes around it, and you want to be in the top and this bottom part right here. And if you plug it in there, you'll still get an electrical connection, but it's likely that if it has any stress on it, it could come off. So you just got to be cautious doing that. I just did that and was lucky that I caught it. I thought I had everything on there just right, and I just, out of luck, I caught it. So anyways, just make sure you're not plugging the male in between here and there. Plug it in between here and here. Alright, so I can't get any happier than that. Now I'll mount this back together. The gasket's still good. There's a little tear right there, but the gasket's still good. And I'll plug this back in. Now the one thing that you want to be cautious when you are plugging this back in is that when you're screwing these back into this cast frame, one, you don't break the bolts, and two, you don't strip it. So just do it by hand until you get it in there a little bit, and then you can tighten them down, and you can use a gun to tighten it in. Just make sure it's on the lowest setting possible, speed wise and tension wise. And then the second thing is the best thing is just use a 5/16 nut driver and just be done with it. I use a gun, so that's what it looks like put back together. I spun them in there with my drill and then hand tightened them, and we're good to go. And as you can see, that looks like it is from the factory, with the exception of now it has 25 foot of actuator cable going to it. Hopefully that'll be enough. I wanted to show you this mistake because I typically don't do this, but as you can see, when I was welding over here, when I was welding the bracket over here, because I'm concerned about the manual pull pin and the actuator arm lining up so you could pull it out, because I'm concerned with that, I always leave the arm on there, make sure I can pull it in and out easy, and just put a little tack weld. Now this time I made a small mistake, but it's easily corrected if you know that you've done it. And you can see that on here, you see this little slag left over from the weld, or splatter left over from the weld. If that arm retracts into here, and as of right now it's not set to, if it does retract in there, there's seals in here and felt in here that it'll wear groove in there, and then everywhere where that groove is worn will suck water into it. Now over time that'll be an issue, but you want to catch that. Now one of the things that you can do, and you've got to be real gentle with it, is just take your wire brush and just brush it. You don't want to brush it too heavily. It's gonna be tough to do with two hands, or with one hand rather. So you don't want to brush it too heavily. just want to knock those little burrs off. And you can knock them off one at a time if you have to, and I may have to with these. That's something you just got to be cautious of. If you make that mistake, just knock those off. But you don't want to make a divot inside of here any worse than you already have, and then you also don't want to leave this, because it'll obviously again bust the seal in here or wear the seal, and that'll possibly shorten the life of the actuator arm. Just a cautious thing. It happens every once in a while. You can just see there's a couple on there, but I'll brush them and it'll be okay. You extend the arm out just a tad bit, and that way make sure you're not ripping the seal over here if you're brushing it, and then you just brush it. And I'll turn this just a little bit so you can see. So you can see there's just a few little divots in there, but that'll be okay. But that's just a trap. You got to be careful. If you're not paying attention to what you're doing, you might not be able to fix it. So the main thing is I want to just feel that and feel it's smooth, and it is. And you can see as I turn it, see one little, it might just be just a black smudge, but there's one little spot that I just saw. No. I'm looking at this edge right here. Get out of focus. Alright, so anyways, we're good to go. So we'll track this back in a little bit, and there we're good to go. I guess one thing you could do is, if you wanted to make sure you didn't do it, is just, if you've got enough room in the arm, just extend the arm out past where those little that splatter is. Alright, so that's it. Now we've got this mounted. As you can see, the pin comes in and out smoothly. Like I said, smoothly. Anyways, wear that in there just a little bit. So it comes in and out smoothly. So that was the goal with that. And I'm doing it in the closed position. If you get it level in the open position to where it's easy to come in and out, but not in the closed position, it doesn't do you any good. Because the only time that they're going to be concerned with getting this pin out is when it is in the closed position. So we're good to go, and extend this out just a little bit more. Now this is not something you need to be doing at home. You need to adjust that actually in the arm, but I'm doing that for a reason. You need to adjust that in the limits, but I'm doing that for a reason. So it is not something that is recommended. We've got our arm level, as you can see. If it's in the line, it's fine. We've got actuator arm back here level, and you can see that I just got it tacked. I got a good fist in between the gate and the actuator arm, and now I'm just going to make my connection over here on this side and run the actuator arm and get the limit set, because obviously we don't have it. We don't have a saw cut in the ground over here to run the wire from one side to the next, so we need to still test it and make sure everything's good so we can burn our welds in for the drop pin plate, and then the support arm for the actuator. Finish welding those, but I've got to be able to run it open and closed to make sure I got my angles right. But one thing that we can also do is just push the gate all the way open, and then get an idea of what the spacing is in between the arm. And again, we've got a fist there, so we're good. Yeah, you know, I'm going to go ahead and burn it in. I'm confident that that's not going to be an issue, so I'll burn it in right now, and then that way I won't have to make this connection twice. But that's not what I typically do. I typically run it a couple of times. I run it one time and make sure I've got good clearance, but We're not going to do that today. We're running out of daylight, and we got to come back anyway. But if we can get everything welded now, we won't have to set up for the welder. All right, so this is an example of a saw cut that's not wide enough. You can see that I can't even push it down in there, and you need it to flow just like that. You need to be able to put it in there, and the reason why it's wider right here and it's easier to do because you can see there's actually been 2 cuts. There's one there and one here. Now the problem with that is because it's not straight, is right here where the bend is, it's a little bit wider because that cable, the actuator cable, has to make that bend, so it's sticking out just a tad bit. But I think this one is just not as wide as it needs to be. So overall, see, like right there, that's how it should be. It should be where you just flow it in there. But that one little spot over there, guess I should have straightened out the cable before I started the damn video. That one little spot over there is going to cost me 30 minutes trying to get it out with my grinder. Alright, I think that's good to go. It wasn't pressure washed, which is typically done, and then I'll run it up there. You can see that I've already got 2 straps for the conduit that's going to go up there. So let's get to work. Alright, so getting back to this, I've now used my air compressor to clean it out, and I've dug a trench from there to that side, and that'll take the wire and the conduit in there. But here's one of the reasons why I always like to be here when they're doing the saw cuts, is because what happens is they do stuff like this where you only have about a 1/2 inch depth because they made a mistake. They plunged real deep right there, which is perfect. That's exactly what I need. But prior to getting that, look at that, they raised all the way up here, and you can see how much of a, it may be hard to see, but you can see how much, maybe you can see how much a drop there is just by looking at the teeth on the saw. So there's an inch drop right there. So anyways, they needed to keep going all the way through there and get that in. So what I have to do is now take an angle grinder and cut that out. And that's never fun because, one, I can't get as deep a cut, and 2, there's always little ridges and cuts and all that stuff. So anyways. Okay, so you can see I've got the conduit going all the way up to the top of the support arm bracket, and no box, no nothing, because when you're standing right here, you can't see it, and it's well protected the way that it is. So adding a box there would just look ugly. So once this gets spray painted black, it's going to look really nice. Then we'll paint it black all the way down to here, and then as you can see, I filled the dirt back in, and you see how the conduit goes into the concrete, so I don't have to worry about edgers and stuff like that nicking the wire unless they get way deep down in there. And yeah, well, you know what I mean. It was not likely that they'll get down in there and bust it. So you apply back a rod as needed. In this case, I've kind of got a wavy saw cut, so using it sparingly, and that should be good. Still should get a good seal on it. And you can see now I'm over here at the same stage on this one. I've got my knockout in the operator housing filled with a 1/2 inch flex fitting, and I've already got my straps on there ready to go. So now I'll just prep the flex right there and run the cable through it, and terminate it with the remnants of what was left over from the actuator arm, which is in another video. Let's see, what do we got? Alright, so that's what we'll do next, and we'll seal this. Is going to be the last step because we don't want to keep walking through it. So we're going to do that, then we'll do photo eye, receiver, and that's going to make this thing about 99% done. Alright, looks like we're getting down to the end of it. Maybe a little touch-up paint here or there, but you can see that we have, may not be able to even see from that angle. We've got the actuator cable locked up, ready to go. Got it set over here on this side. Get this backer rod up here like that. And we got that. We got the photo eye wired. Got it upside down. Cosmetically, it's going to look like that. It's going to look better. And then you got the antenna, which was installed yesterday. And we won't need the photo eye hood, so we'll just put that in there just in case we need to flip it back over. This will be the first time that I've done one upside down. You can see everything came together pretty good. You can see everything came together pretty good, and looking good in there. I'm going to put that cover on that receiver here in a minute. I just haven't done it yet. So that's pretty much about it. I gotta get the code to the keypad from the customer. I got it mounted up over here. Once I get the code, then I program it in and get the receiver cover on, and then that should be it. That should be done. So got a customer next door. Gonna go service them here in a minute. Now we'll just clean up. So we got the photo eye set up and ready to go, and you can see, block the photo eye, gate opens back up, and then we have the sensitivity set correctly. Oh, I blocked the photo eye. Alright, and for this little gate, that's about how sensitive we want it. So the only thing that I've got left is to seal this and do the keypad, program the keypad. But so I just wanted to give you a final look before we seal all this stuff up. Alrighty, we'll get the keypad code and the sealant done, and then we'll be good.
Yours is a little different because it's detached. You want to open the gate, you don't have to get into the remote. So this is a thought.